This is 9-7. We're going to be taking a look at the vertical shift of trig functions. So we're going to identify the vertical shift using the definition. Remember, these are our parent graphs. We have our cosine and our sine parent graphs. We need to have those memorized. If we have these memorized, the rest, it's going to be just repeat the same thing over and over again. So what is the vertical shift? Now, if you guys remember from our old parent functions, we're just adding these to our list of parent functions. We call it d, okay, but it's essentially the same thing as a k, right? If you remember, plus k shifts our graph up and down. Same thing here. And so because of this plus 4, that means literally every single value on my graph shifts up 4 spaces. So if you count it, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. So every single value shifted up 4 spaces. Now, one of the things that I like to do is, remember how I said that this is our center line? The center line shifts up 4 spaces. And so then you can graph your sine graph, in this case, around that center line. And so we're shifting the center line up, and then we can draw it around the center line. Let's look at another one. Cosine theta minus 5. So for this one, if this is my center line, it's going to shift down 5 spaces. So that'll go down to -5. So this being my new center line here, now I can go through amplitude, cross, below, cross, amplitude, and then it fits the graph perfectly. So if we just imagine it, that we're just shifting the center line up or down, that's what the vertical shift does. As long as we have the parent graph memorized, it's easy. So now what we're going to do is we're going to take every little bit that we've learned so far and we're going to compact it together. So we have amplitude, we have period change, we have horizontal shift or phase shift, and then we also have vertical shift. And so we're going to take all of those, we're going to combine them together into one thing, and then we're going to graph that. So for this one, my amplitude is 1. It's a sine parent graph, so I know that the pattern should be something like this. And now I need to find what these values are, right? What are those x values? And so I'm going to take whatever's on the inside and put that between 0 and 2 pi. And so add 2 pi. So I get 2 pi is less than or equal to 3x, which is less than or equal to 4 pi. And then divide everything by 3. So I get 2 pi thirds is less than or equal to x, which is less than or equal to 4 pi thirds. So now I can do the box. Now I may have to do some scaling, and I talked to you guys about the scaling part. So here's 2 pi thirds, here's 4 pi thirds, and so to find the middle value, add the ends divided by 2. Because of limited room, I'm going to write it here. So that's going to be 6 pi thirds over 2. That turns into 3. The 3's cancel out, so you get pi. So now add these two ends to find the middle value. So 2 pi thirds plus, now since it's pi, I'm going to change it to 3 pi thirds. So I can combine them together, found the common denominator. So you're going to get 5 pi thirds over 2. That's going to give me 5 pi 6. And then to find these two, I'm going to do the same thing. That gives me 3 pi thirds plus 4 pi thirds. Just found the common denominator all over 2. And so that's going to give me 7 pi over 3. Multiply that by 2. So that's going to be 7 pi 6. So now scaling this to make it a little easier, it looks like the common denominator is going to be 6. So this will become 4 pi 6, 5 pi 6, 6 pi 6, 7 pi 6, 8 pi 6. And so now on the number line, I can label that. So 1, 6, 2, 6, 3, 6, 4, 6. So here's 4 pi 6, 5 pi 6, 6 pi 6, 7 pi 6, and 8 pi 6. So the other thing, that plus 4. So that's going to shift my center line up to 4. And so now I can go ahead and graph my pattern. So it starts at the center line. There's my first value at 4 pi 6, which I found here. And then 5 pi 6, 6 pi 6, 7 pi 6, 8 pi 6. And so there is one rotation, or one cycle. So literally, I did the entire thing. Nothing has really actually changed in the process for me to graph this sine graph. The only thing that we added new, I just shifted everything up 4 because that said plus 4 right before I did it. I didn't do it around the x-axis because that's no longer my center line. That plus 4 says your center line is now at 4. And so I did everything around that line. Let's try another one. 4 cosine of pi x minus 2 minus 2. So my amplitude, that's going to be 4. Because it's cosine, my parent graph, cross, below, cross, above. So there's my parent graph. Then we also are going to have, I'm just going to write it out, my vertical shift is minus 2. So I already know, just in case we forget, that my center line is going to be at minus 2. Alright, so let's figure this out. So I take whatever's on the inside of my function, and I put that between. So there is a typo in this problem. I'm going to add a pi there. There's supposed to be a pi there. Okay, so I'm going to add 2 pi. So 4 pi is less than or equal to pi x, which is less than or equal to 4 pi. Then divide everything by pi. So the pi's cancel out, and you're probably thinking, wait. How do you graph this if there's no pi? That's okay. Just look, now it's just numbers. It actually might make this a little easier. So 2 and 4, well, the middle of 2 and 4 is 3. The middle of 2 and 3 is 2.5. Middle of 3 and 4 is 3.5. So maybe we can label these by 0.5s. So there's 1, 2, 3, 4. That might make things a little easier. So graphing cosine around the center line. So it starts, so if this is my center line, right, everything shifted down 2. That means that starting up at the amplitude, so 1, 2, 3, 4. Then at 2.5 it crosses. Then at 3 it goes below. Remember, the amplitude is 4, so that's why I went 4 spaces. It's 4 spaces, 1, 2, 3, 4. 4 spaces, 1, 2, 3, 4. Then it's going to go back to the center line, and then it's going to go back up. And so that's my graph. And because, I mean, it's just decimals, so technically you can keep going. You can do 4.5, 5, 5.5, 6, etc., etc. So you can just keep going. So what did we learn today? We learned about the vertical shift on trig functions. And so how do we find it? It's whatever that value we're adding or subtracting to our function. And just remember, if we think of it as the center line is normally at 0, and the center line is what gets shifted up or down with that vertical shift, then it's much easier to draw our graph around that center line. So this does conclude our lesson. If you have any other questions, please leave them in the comments.